Hi everyone, let's talk about another Leetcode problem, and today's problem is a premium problem and it's also categorized as a hard problem. So this is problem 1063, number of valid subarrays. So obviously you can understand that in the input we are given an array and we have to find out the number of subarrays with a specific condition. So the condition is like we have to find out all the subarrays where the leftmost element of the subarray is not larger than any element in the array. And from the definition of the subarray, we know that the subarray is a contiguous part of an array. Okay, so there cannot be any gaps. So a set of numbers which are like contiguous in the array actually create the subarray. So with that condition, let's see this subarray, say 253. As you can see, the 2 is the leftmost element, and this is the smallest of all the elements in this subarray. So 253 is obviously an answer, right? So you can see 253 is an answer here. And then let's look at, say, 1. 1 itself is an answer, right? A subarray 1, 4 is also, it also meets that condition. The leftmost element 1 is smaller. Even if I expand, so 1, 4 is another, right? 1, 4, 2 is another, right? 1, 4, 2, 5 is another. You can see it here. 1, 2, 1, 4, 2, 5, 3. That is another. So that is, so all of these like meet the condition, right? So we have to find all such subarrays. And in total, there is going to be 11. Okay. Yep. For the second example, you see 3, 2, 1. So if we start with 3, you see we have to stop there because nothing, it cannot expand to any longer subarray because 3 is the largest element. So 3 itself is an answer. Then if we start with 2, again, we have to stop there because we cannot stretch the subarray further. And then 1 itself is another. So the answer is going to be 3. Okay. Uh, so let's look at this example. Let's try to solve this out. Like how many subarrays with that specific condition are there in this array. So if we start with 15, you see that after 15 comes 1. So 15 itself is a subarray. It creates a subarray, but starting with 15, I cannot stretch it further, right? Okay. So that's one subarray starting with 15. But if we start with 1, we see 1 itself is a subarray, then we can actually go 115 is another valid subarray, 115, 12 is 20 is another valid subarray. So if I check all of these, you see there is nothing less than 1. That means starting with 1, I can make this or this or this, 3 of them, then 4 of them, right? And then say I can make this subarray with 5 elements. I can make this subarray with 6, this subarray with 7, right? So they're like in total I can make like 7 subarrays out of this. So this is the brute force method. Okay, so the brute force idea is I start here and then I keep on checking if I hit a smaller number, right? So if I say I hit a smaller number here, immediately I stop and add 1. Second, I start here and then I keep on checking and see that there are 7 elements and still I didn't hit anything less than 1. So that means in that case, I add I know that there is going to be 7 subarrays I can create. So this is the brute force method. And for each element, in the worst case, we may have to travel like n times. And then n into n is order of n square, right? So one example is 1, 2, 3, 4, right? In this case, for 1, I have to check everything. For 2, I have to check everything, right? For 3, I have to check everything. So it's going to be for n elements, for each of them, I have to potentially check n elements. So it's order of n squared. This is the brute force algorithm. Now let's try to see if obviously we can try to do better, right? Is the number of subarrays that we can calculate in the same way that I just showed you, right? But how can we actually find all of these like in one pass? So very carefully looking at it, you see that there is a violation here, right? That means this one is smaller than the previous number. So any subarray starting with from 15 just stops here. It cannot go any further. Then there is violation here, right? Because this one is smaller than this. And similarly, we have a violation here, right? This one is smaller than the previous one. Okay, so that means we can start reading from the left, right? We can start from reading from the left, and whenever there is a violation, we can actually go back and see how many subarrays can be made, right? And we don't want to go back all the way. So we just want to go back once and do our find our results. For that, what kind of data structure we can use? Obviously, we can use a stack, a monotonic stack. Let me show you. So we'll start reading from the left. And whenever there is a violation, that means its number is smaller than its previous number, we'll just go back and check how long that subarray was, right? So that means this one was stopped here, how long that subarray was. And to get the length, instead of just putting the numbers in the stack, we should put the indices of the numbers, right? And that way we can immediately say how long the subarray was. So we put index 0, right? Next we read this, and we see that this is already smaller than the 15. So what we do is, I know that there is a violation here, right? So that means I go back to the stack and see the top of the stack has number 0. I am now at index 1, right? So 1 minus 0, that represents this. So in the result, I add 1. That means this one I add to the result, right? And then I put index 1. Next, I keep on reading and I put index 2. Index 2 is fine because 15 is greater than 1, right? So there is no issue here. Next, I read 20. I put index 3. So you see here that there is no issue here because 20 is greater than 15. Next, I read 10, and this is index 4. Now you see that there is a violation. That means whatever subarray was being built up, right? That one cannot go any further. So it has to stop here. So what we do is we just go and check the top of the stack. That is 4 minus 3. 4 minus 3 is 1. That means we know that starting from 20, the maximum length subarray is 1, right? So I take this 1 and add it to the result, right? Next, and I also take this out of my stack. Next, I check and see that my 10 is still greater than this. That means 15. That means starting whatever subarray started from 15, it cannot go beyond. So it stops here, right? So 4 minus 2, the current index is 4 and the top of the stack is now 2. So 4 minus 2 equals to 2. That means starting from 15, we can have only 2 subarrays that are valid. One with 15 itself and the other one was 15 and 20, right? Okay. So 4 minus 2 is equals to 2. So that one actually is this. So I add this, right? And I take 2 out of this stack. Okay. Next, I check 4 and 1. And you see 10 is greater than 1. So that means we are fine. I don't need to worry about anything. So I put 4 in the stack here. Next, I read 17, right? 17. And there is no issue between 17 and 10 because 17 is greater than 10. Next, I read 19, which is index 6. 19 is greater than 17, so no issue here. Next, I read index 7. Again, this is 17, but as soon as I read this, you see that there is an issue with this is actually smaller than 19. So that means it cannot go any further, right? So immediately I go and check the top of the stack. which is 7 minus 6 equals to 1. So that means this one is now being added here, and I take this out of the stack. I also check between 7 and 5, which is both of these are the same number, so there is no issue here. So that means there is no issue here, and I put 7 here. Okay, so far we had put, you see, these 4 things right into my result, and we have reached the end of the stack. That means whatever is left in the current whatever is left in the, okay, so I made a mistake. 0 had to go away, right, from the stack. So whatever is left in the stack actually extends to the end, right? So it extends to the end. So you see that starting from index 1, it extends all the way to the end. That's why it's in the stack. Okay, so this is the second pass. Now in the second pass, I just read from the stack. And I know the length of the stack, length of the array is 8, right? Length of the array is 8. So I just read from the top of the stack. So 8 minus 7 equals to 1. That means starting from 17, there is a length 1 subarray. Like there is one subarray, valid subarray. So I take this. Okay, next I read 5. So 8 minus 5, right? So this is the index 8. So 8 minus 5 equals to 3. So I take plus 3. So this one is basically this, right? I take this out. And then I read 4. 8 minus 4 is 4. I take this out. Then I read 1. So 8 minus 1 is 7. And that is this, right? So this way I just added everything to the result, and the total result is going to be 4, 6, 9, 20, right? So the result is 20. So there are 20 valid subarrays. And as you see, we just read once from the left to right, and we kept on putting into the stack. So we kept putting into the indices into the stack once, and then took them out once. So if there are like n elements, we had to do like inputs and or n pushes and then n pops, right? So n operations. So, and we read from the left to right just once. So it's order of n, right? So it's an order of n thing. So that's the time complexity. And the space complexity, you see, in the worst case, we have this monotonic stack all full, right? So in the worst case, everything goes in here. So that's also order of n. So what is an worst case example? Say if my input was, say, 1, 2, 3. So there was never a violation. So I would have to put 1, 0, 1, 2, 3, all the indices here without popping anything. So that's order of n thing. So let's check the code here. As you can see, we have this result integer result to keep track of the number of subarrays, and we have this stack that is going to be used as monitoring stack. We read from the left to right, and if the stack is not empty, and if the current number is smaller than the number that is on the top of the stack, or the number that is at the index, which is at the top of the stack, in that case there is a violation, right? So what we do is we just take the difference between the current index and the top of the stack index, and that one gives my and add that to the result. I just demonstrated you, and then I take that top of the stack index from out of the stack, right? And I push the current index into the stack. Okay, so I will keep on doing this part until the violation keeps on happening, right? Okay, so that is the first pass. And then we showed you the second pass. In the second pass, there might be some indices still in this stack, right? So we keep on reading this, and every time from the length of the array, we subtract that index and add it to the result until the stack is empty. And finally, we got all the values, all the numbers added into the result, and we return it. So I hope you understood the problem, and that's it for today, and we'll come back with another problem next time. Thank you very much.